Hi, I'm Olga. I work for Microsoft SQL Server. I would like to present our project Moneyball, proactive autoscaling in Azure SQL Database Serverless. All cloud service providers have recently moved from provision to serverless compute. Provisioned compute means that a fixed amount of resources is allocated, and it doesn't change unless the customer manually requests a different amount. Rigorous resource analysis reveals that resources tend to be underutilized. To overcome this limitation, serverless compute was recently introduced. It scales resources based on demand. When the customer logs in, resources are resumed. When she logs out, resources are paused, reclaimed, and possibly assigned to other active databases. Unfortunately, scaling policies were merely reactive. In this work, we aim to overcome reactive nature of serverless compute and make scaling policies proactive. A database is either resumed or paused. When the customer logs out, there is a pause workflow which takes resources away from the database. When she logs in, there is a resume workflow which assigns resources to the database. Unfortunately, these scaling policies are not instantaneous. Therefore, there might be delays in resource availability on login. In this work, we analyze typical resume patterns per database and time. And if the probability of resume is high, we proactively resume resources at the beginning of the time window, such that when the customer logs in, resources are already available. However, if we resume too far in advance, resources will stay idle, and operational costs will be wasted. So our first goal is to enable proactive resume while minimizing operational costs. On the other hand, it is not effective to pause resources for short idle intervals. In this case, resource availability time will become too fragmented for effective reuse. Therefore, we aim to reduce the backend workload and avoid pausing resources for short idle intervals. However, if we do not pause resources for long intervals, they will stay idle and operational costs will be wasted. So our second goal is to reduce the number of ineffective pauses while minimizing our operational costs. The Moneyball problem space is two-dimensional. On the x-axis, we measure the percentage of correct proactive resumes, and on the y-axis, we measure the percentage of avoided pauses. These two goals are in conflict with each other. Namely, if we maximize the number of proactive resumes, some of them will be wrong unavoidably, meaning that the customer will not come online as expected, and some of the pauses will be ineffective. On the other hand, if we try to reduce the number of pauses, we will also reduce the number of resumes and make the task of correct proactive resume even harder due to sparse data. Our baseline solution is reactive. It does not avoid any pauses, and all resumes are reactive. An unrealistic optimal solution would make 100% of resumes proactive and correct, and also avoid up to half of pauses, and the avoided pauses are the shortest to minimize resource idleness. The area between these two extremes is the room for improvement. Our goal is to get as far as possible to the right, even though unrealistic optimal solution will never be reached. We analyzed 6 months of production telemetry from tens of Azure regions where tens of thousands of serverless databases are currently deployed. Given the size and scope of our analysis, we believe that the usage patterns we observed represent the behaviors of any serverless databases in any company. We included all features which can be useful for load prediction into our analysis. First of all, we classified serverless databases into stable and unstable. Stable means that a database is either paused or resumed 30% of the time. And unstable is further classified into those that follow a pattern, meaning that 30% of pauses and resumes happen within a time window W. Remaining databases follow no pattern, and they tend to be unpredictable. Even under strict constraints, when theta is equal to 90% and the time window is 15 minutes, a very high percentage, 74% of databases are stable. 3% follow a pattern, and 23% follow no pattern. We ran several machine learning models on both predictable and unpredictable databases. We trained these models using 3 weeks of history per database, and we predicted pause resume pattern per database 1 day ahead. The time series model, we used NimbusML in this case, performed the best. Therefore, we will include NimbusML in our further analysis. Recall that our first goal was to enable proactive resume. This example shows the pause resume pattern of a database for 8 weeks. At first sight, it appears to be completely unpredictable. However, a closer look reveals that there are resumes that happen at about the same time on the same day of the week. So there are 7 resumes between 5:40 and 9:20 on Wednesdays. Basically, only 1 resume is missing. So if the probability of resume is high during a window, we can proactively resume a database at the beginning of the window, such that when the customer comes online, resources are already available. Alternatively, we could run a machine learning model and predict the pause resume pattern per database. And if at least 1 resume is predicted during a time window, then we proactively resume at the beginning of the window. We compared these 2 approaches, probabilistic and predictive resume, and we concluded that probabilistic resume makes 56% of all resumes proactive and correct, meaning that the customer will come indeed online as expected. Predictive resume increases this percentage to 80%. Unfortunately, predictive resume also has 5x more wrong resumes, meaning that the customer did not come online as expected, and therefore the cost of predictive resume is 5x higher than for probabilistic resume. The cost is computed as the ratio of wasted cost to the total cost savings. Therefore, we currently implement probabilistic resume for SQL Server. Recall that our second goal was to enable effective pause. Basically, we want to avoid pausing a database for short idle intervals. We considered several solutions, and due to time constraints, I will only describe one of them, which is currently deployed worldwide. The idea is very simple. It is called logical pause. So when the customer logs out, we do not immediately take the resources away, but you wait for some time interval called logical pause, and if the customer comes back online, resources are still available. So the advantage is that we avoid short pauses, so the first short pause is avoided. However, long pauses are also shortened by the duration of logical pause. To overcome this limitation, we predicted the duration of a pause. And if the predicted duration is long, then we can immediately take the resources away. So in this way, we would avoid short pauses without making the long pauses shorter. We compared greedy and predictive logical pause. Unfortunately, predicted pauses tend to be shorter than the actual pauses. Therefore, predictive logical pause avoids up to 19 more pauses than greedy logical pause. And therefore, predictive logical pause has up to 4x higher cost than greedy logical pause. Therefore, we have deployed greedy logical pause in all Azure regions. Let us revisit the problem space of Moneyball. Remember, it was 2-dimensional. On the x-axis, we measured the percentage of correct proactive resumes, and on the y-axis, we measured the percentage of avoided pauses. Our baseline solution is reactive. It doesn't avoid any pauses, and it does not enable proactive resume. The unrealistic optimal solution makes 100% of resumes proactive and correct, and avoids up to half of pauses, and the avoided pauses are the shortest. The area between these 2 extremes was the room for improvement, and our goal was to get as far as possible to the right, even though the optimal solution will never be reached. So the greedy logical pause avoids up to half of pauses. When we combined greedy logical pause with predictive resume, we can still avoid up to half of pauses and make up to 80% of resumes proactive and correct. So the area which is striped is the impact of Moneyball. To achieve high quality of service, we are currently implementing probabilistic algorithm to enable proactive resume. To reduce the backend load, we avoid pausing resources for short idle interval. To this end, we logically pause a database to make sure that resources are still available if the customer comes online after a short idle interval. Logical pause is currently deployed worldwide. I sincerely thank my collaborators and advisors at Microsoft for making this work possible.